Okay, how's everybody doing? Good? Thumbs up? Everybody's doing horribly. There we go. Well, welcome to the show. We've got a bunch of new folks coming on, I presume, tonight. So, a new course started today or yesterday. Some old friends and new friends today. And so, what we're going to talk about tonight, what I wanted to put on the table is wildfires and EM tools. Primarily, why? Do you think that's an important thing for us to look at right now? For anybody that's on the West Coast, I think it's self-evident. We've got a lot of smoke. I can't go out for my run right now. I'm in Vancouver because I fear that I don't want to really get particulate matter in my lungs. It's not that bad now, but it's not great, better than it was. And I want to focus on wildfires because you hear a lot of like misinformation out there about wildfires. And I'm not claiming to be an absolute expert on it, but I've studied it in South America for a while, and I know what's going on currently with this issue. So I want to kind of deconstruct it and then present some resources and ideas to help you just kind of better navigate what this issue is all about. Specifically, if you've been watching the American news at all, you'll see this is becoming highly politicized, right? How's it becoming politicized? Anybody? What's going on? Trump's fault. That there's fires, that there's wildfires. Yeah? Yes. Of course it's Trump's fault. Couldn't be anything else. There's that, because of the election coming up, but also analyzing the issue, which I find quite interesting, because everything's so polarized right now along certain issues, policy issues. So if you saw the news at all, you'll see that now Trump is becoming persona non grata because of his position on climate change, which obviously has a very kind of conservative view of the issue, if not like downright like refutes the idea. And so this is becoming a dividing line. So, but what I want at least tonight is to at least give you some things to look at so you know what is what. Because it's not one or the other. It's not like you believe in climate change and it's causing forest fires and that's the solution. If you don't have a good climate policy, then you're an evil person and a climate arsonist, as Biden was saying. You know, there's elements of truth to that, but there's also other issues that you have to account for. And then on the other end of the spectrum, it's all about forest management. Well, it's a big part of it is forest management, but there's also other latent issues that are contributing that are longer term, like it appears that climate change is a big component we need to think about too, that need to be factored into that reasoning as well. All right, so we're going to get into that tonight and then also put that to the test of our rural roads courses, if you're taking rural roads courses or having taken them, as to what can you do with that then, given the fact that you've got some knowledge or you're getting knowledge about the underlying content and environmental management tools. So first and foremost, like all these issues, why is this something we need to think about? Well, if you're in the Lower Mainland, the last few days have been the worst air quality in the world over the last 4 days, as it has been reported, right? And if you look at the news from the United States, you can see that with these links here, things are not going so well in California, in the Pacific Northwest, so like in Oregon, and Washington State as well. This is third, and I've chosen from 3 different sources, CBS, CBC, and Fox, to give you even Fox, which is a conservative news outlet, is reporting on these fires. It goes across political divides, what's happening. Now, how we respond to it is different. So there's a problem here, right? Wildfires are happening and we're seeing kind of health impacts in urban regions like Vancouver, then the obvious immediate effects in the regions in California where People are losing their homes, in some cases even losing their lives as a result. Big issue. So this is the stuff that we work on if you're a rural roads environmental professional or student. This is a textbook thing that you could be hired to work on. So what's the deal? What is the problem here? Why is it so bad? Like, why is it so bad now, seemingly, as it has been before? Than it has been before. Well, I mean, it's not just one thing. It's actually a combination of different things if you want to look at research and assess what's going on. And I'm going to give you some things to look at. So for those who are new to these podcasts, we do it live. You can ask questions and contribute on the text. I'm going to send in links as I go. And then all of the links and all of this stuff, like the links, are going to be shared on the YouTube. So when you go to the YouTube upload, in the discussion, you can download a document, which is the notes, which has all the links from this presentation. So you can take these notes if you want, but they're going to be available for download after. So don't worry too much about that. So it's a combination of things: forest management, climate, weather, and population as well. More infrastructure means more risk, right? More exposure. So the thing is, how do we deal with it? So when you're approaching this subject matter and this problem right away, what do, right? Well, this is what I do, is you need to deconstruct the problem. Really break it down and try and attempt to understand all of the different variables that are at play in the situation. Okay, because there's a bunch of things going on at the same time. So what we want to do is kind of deconstruct it. Like, is it all about bad forest management? Is it all about, people building in bad places? Is it all about climate change, right? Well, you don't know. Like, you have to really look at good sources of information to really break this apart. So the first thing that I would recommend, if I were to approach this, say in Canada, for instance, is to try to find a credible source of the trends and say, okay, well, really, what has been happening? What is happening in this region? Okay. So here's a link to a paper that I found that's a really solid paper, and you can go to that link and download the PDF of that, and so you can see exactly what is going on, and that will give you the actual breakdown of what has been happening. So if you go to that right now, I'm just going to speak to that paper. If you go on that link and download the full text PDF, that will download for you. So this is a great paper because it's, this is a 2000 and when is it? 2018, I think, something like that. Yeah, 2019, actually. So this paper here is free. It's accessible from the NRC, National Research Council, Fire Regime Change in Canada over the last half century. So if you take a scan of this, you can see on page 258, that's the third page in the PDF, page 4 of the PDF, you'll see a map of the different regions, and you see the fire frequency per decade. So 2010 to 2015, 2000 to 2019, and see exactly where all the fires occurred and when they occurred. That's an important thing to know, is like, where did they occur, when did they occur? The next important piece of information here that I think is to look at is the frequency, the number of fires and the area burned. So if you look at, it's the 5th page of that PDF, or on the actual art and the publication, it's 259. And you can see from 1959 to 2015, the kind of changes in the number of fires and the area burned, right? So if you look at that, you can see that there's some patterns here, right? It seems as though there's an increase in the number of fires. Now, over time, you can see it was quite lower in the 1950s and so forth, like on average, but with some periodic spikes. And typically, those are associated with cyclical phenomenon of various sorts, like a drought year or something like that. And then you get some areas with huge years, but you can see that there's a general increasing in trend if you look at that bottom line of just increased number of fires there. All right. And then if you scroll down, you can see on the page, which is the 262, which is page 8 of the PDF. This is an interesting one because they have a trend line that they've created. over from 1959 to 2015, and you can see that there is a trend in area burned. So there's an increase in area burned over that period of time. And actually, the trend line is slightly negative from 1959 to 2015 in terms of the number of fires. So it shows you that there may have been less fires, but bigger fires. That's kind of one quick assumption people can make from that. All right. So you can then, I mean, this is what you need to look at to see, well, what's happening in the different regions, in the overall trends and the fire sizes. You can see fire size. There's one on page 12 of 15 that the fire size on average is getting larger, right? This is the type of analysis you want to start with to say, okay, well, is this a real problem? And take a credible approach to look at what's been going on. Okay, number one. So you have that now. You can look at that in detail and dig into that paper and say, well, actually, according to the research, there has been an increase in the amount of area burned in Canada over the last 30 whatever years. So that's the first thing, to look at what's been happening. And then the next thing is to think about what are the contributing factors. You know, what contributes to that, right? Is it poor management? Is it climate or whatever? And there's a lot of different things there. That's where it gets kind of messy. But one of the things that I want you to point you to do is, because it's coming up so much in the United States, is it purely climate? Well, if we want to really get to the bottom of that, we need to look at an actual paper that assesses that. So here's a paper found. This again is focused, I'm only focusing on Canada in this presentation because, you know, we're in Canada and let's just focus on Canada. So if you look at that paper, again, this is one that you can download. Fire frequency occurrence and climate change in Canada. And this one is a bit older now. This one is, I think it's 2014. Okay, let me double check that. It's actually 2010, this one was, but it's a good paper. So what this one will show you is how you go about assessing that. So what they did with this is they used global climate model output and broke it down across Canada, as you can read in the methods, and look at, okay, what climate models they used, and then also looked at future fire weather scenarios running GCM, so global climate model, that are GCMs that are used in the scenarios for the IPCC, which are, this is credible stuff, and then looked at, you know, what you can expect as a result of that. So, and then the modeling techniques that they used and so forth and so on. And you can see that they give you the actual fires that have, so if you look at page 259, that's page 8 of the 20 on the PDF, they give you the frequency of number of fires, the actual measured frequencies. You can see there's a lot in BC, in certain parts of BC and Alberta. And then they also look at lightning-caused fires. That's the other thing. Is it lightning or is it anthropogenic? It's roughly 50-50 usually in a lot of the data that I've seen, generally speaking, that half of the fires are lightning-caused, half of them are from human sources. And then they give you an average annual human-caused fire occurrence rate from the baseline GCM scenario. So they project forward what you can expect to see that, and then they do some correlations, predicted number of fires versus observed. This is how you validate your model, is you looked at the observed versus predicted. This is on page, this is always something you want to do when you look at this, page 11 of that 20 on that PDF. You see this observed versus predicted number of fires, and you want there to be a linear correlation between that, and you dictate whether it's accurate based on the R-squared, how much those vary from predictions versus the actual measured. And then they look at the future predictions, 2090, 2030, and so forth, based on the estimated temperature changes. Okay, and you can see there, that's how you get at, credibly, whether or not there's going to be some projected increase in fire frequency, right? And so if you look on table 4, which is on page 268 of that paper, you can see that they've broken down that through, they've used different models, the Canadian Climate Center and the Hadley Center model, and different time frames, 2020 to 2040, 2080 to 2100, to determine what you can expect in the projected increase in annual fire occurrence rate. And so you can see that if you look at that, hopefully you're able to see that on that paper. I'm just going to go. You can see that on that, if you're there, this is on, again, on page 17 of that last PDF. or 268 of the paper itself, you can see that there's a quite consistently more fires in 2080 to 2100, as well as 2080 to 2099 from the Hadley Center model, as opposed to 2020 to 2040, right? That's what you would expect based on the projected increases in greenhouse gases and what we understand from how climate change is working. And it's pretty significant in some cases. Like in Ontario, there's a very significant percentage projected increase in total annual fire occurrence relative to, it's basically more than 3 times the number of fires, right? It's actually quite similar, the rate of increase. It's 3 times almost across the board, it looks like. But that's legitimized based on a model output. It's not hypothesized, it's not a guess. It's on a pretty decent models that, and they've validated those models based on looking at the observed versus actual modeled, predicted. All right, so this is the basis then that you need to use for assessing, you know, is this a climate problem? And this is where I'd refute Donald Trump. I'd say, look, I mean, I understand that you may not believe in this stuff or what have you, but, you know, the science is pointing in a direction that indicates that we're probably going to have more arid conditions, and those arid conditions will lead to more fires. And we see that in the data, and we're seeing that in the models going forward, right? So this is how you defend a position on that with credible sources. This is not like, you know, it's not a publication from it's not an advocacy-based publication. It's from science. It's the National Research Council. Okay, so that's where we start with that. Say, okay, there's some trends here that we need to bear historically, and where are we going, right? So the next question then is, fine, okay, we understand that there's a problem, but what are we going to do about it, right? And this gets into a management situation, right? So this is where you start to look at, well, how do you manage fires? How have they managed fires in the past? And this is a very interesting paper that I'd recommend you take a look at here, which is, it's a recent one. I think this is 2019. Correct me if I'm wrong. I'm just going to upload or open it up. Again, you can access for free. You just click download and it will download for you. Wildfire Management in Canada, Review, Challenges and Opportunity. This is an awesome paper. All right, and some of these authors, Flanagan is on the other papers that I've given you. Wildfire Management Canada, Review, Challenges and Opportunities. They go through wildfire management agencies in Canada are at a tipping point. Pre-suppression and suppression costs are increasing, but budgets are not, right? And they go into this, a double wildfire paradox exists, requiring communities and critical values in wildfire-dependent ecosystems to be fire smart. This is an interesting part of this paper, this wildfire paradox. Why is there a paradox? Why do you think this word paradox is there? What does paradox mean? It's conflicting perspectives. Why is there a paradox here? Why do you think in wildfires in Canada? What's the paradox? Anybody? Why would you think it'd be paradoxical? Paradoxical. I guess my question to you is, are fires always bad? No, exactly. Cindy, no, they're often used for force. Exactly. This is the paradox. Ecosystems need fire, and also controlled burns are often needed, right? Ecosystems naturally, so succession processes and ecosystems need fires. It's a natural process, right? We also need to do controlled burns to reduce the amount of load in fires, right? If you just load up a forest with dry, like what happened with the mountain pine beetle infestation, you had dried forest, like it's a giant gas, you know, it's like having gasoline spread all over the place. If you don't manage that, control that, and you do that through controlled burns and so forth, then it can lead to a bigger problem. So the paradox here is that we need fires, but we don't need fires. You understand, right? We want to avoid fires, but we also need to use fires. So this is where it gets quite interesting from an environmental management standpoint to say, like, whoa, just a sec, these fires getting out of control are problematic because they're damaging property, but they're getting out of control because maybe we haven't had enough controlled burns and so forth. This is where it gets quite interesting. So this paper here is a really good one for you to look at. So I want you to like have an educated position on the wildfire situation. And this paper is going to give you that. There's great content here about how they manage fires. So you look at the second page of this. So this is on page 3 of this PDF, or page, where's the page 2 of the PDF, sorry, of the paper. It's page 3 of the PDF, page 2 of the paper. You can look at here, you see this trend line. So in their study from 1970, so they measured from 70 to 2015, area burned, number of fires. Their trend line, the area burned is, the number of fires is going down, true. That equals what that other paper said. And they didn't do a trend line for the area burned, but the area burned is probably going slightly up, according to the other paper that we looked at, if we did a trend line on the area burned, right? So that's interesting. There's our data. We have to have data. The other thing to look at here, which I find interesting on this page, the same page, is how they frame this in disaster resilience. Because we're dealing with disasters. We have prevention, mitigation, preparedness, response, recovery, and review. These are the dimensions of disaster risk response which apply to forests, right? There's a mitigation part of it. There's preparedness, there's prevention. Like a mitigation is dealing with it, right? When it's a or reducing the impact of it. Response is when it happens. You know, fighting the fire is a response. And then recovery is post-recovery and review what went wrong. Preparedness and prevention, those are other aspects of this. So look through this paper and you can see that it gives you a really good breakdown of how this preparedness occurs in Canada from a national standpoint, what tools that we have, what policies we have in place, what institutions are in place, and then what are some of the issues that we have. Like for instance, on this page 6 of the PDF, you can see by province the mandated area of responsibility, what group is responsible for what provincially, the policy response, so if their emphasis is on life, property, communities, or something else, cultural resource values from Northwest Territories, and then the strategy, how they go about dealing with it. And it actually varies somewhat between different provinces. So this is a great kind of, because you need to look at the governance regime in place for managing it. Otherwise, you're just like, you don't know who's doing what. Similarly, in the United States, they'd have the same idea for the state versus the federal component of this. And then in the same paper, you can see here the number of wildfire disasters is the other thing. Okay, what's the problem? It's a number, we can have another fires, but what are the actual disasters? What's the volume of impact? And look at this. This is on page 8 of this PDF, 8 of 11. Per decade, the number of disasters. And a disaster is impact, right? It's not just the fire, but the total impact. 1980 to 89, there was 10 disasters. 90 to 99, 20. 20 to 20, these are wildfire disasters. 2000 to 2010, we had 32-ish. And then 2011 to 2017, 50 plus, right? Look at the trend, right? So that's a function of a few things. So this is why you have to look at different variables. A disaster is determined not just on the number of fires and area burned, but the amount of damage. So what would be something that would contribute to this? Like why in 1980 might there be, if you held fires constant, more disasters? That's the question. Why do you think, if fires were the same, yet disasters went up, what might have changed? There we go, exactly. Population or I mean, as a function of that, population and infrastructure exposure, basically, right? There may be more population and more infrastructure in regions where there's more probability of fires, plain and simple. Now you have to dig into that really to see that, like look at population density in areas where they were impacted and so forth and so on, right? And this is where we get into like, let's get out of the political realm of saying you're a climate arsonist and you know you're whatever, like it's all about forest management. Those are like simple arguments those people are making for usually for political gains. What we have to do is dig into this and really do a sophisticated or at least somewhat educated analysis. So I would say that most likely, I mean, a big part of that is like there have been more area burned. We've seen that in the data. There have been less fires, but the area's gone up. but most likely there's been more exposure in the areas where there's been fires, right? Therefore, more losses, more disasters. Okay, and we can really get a close look at that. So this paper is a very good resource for determining and assessing what are the management approaches to that in Canada. And this is a gold mine if anybody's interested in fires. If you look at the reference list on the last page, so page 10 and 11 is just, wow, if you want to learn about fires, go to that reference list and you could spend the next month reading all those papers and know a lot about wildfires. All right, so there we go. We've seen the history and we've seen some management. But then another thing I want to emphasize here is there's a scale issue here, right? Like we can look at this from a municipal standpoint, like just in, say, I don't know, where the fire is occurring in Washington State, the communities. We can look at it at the provincial or the state level problem. We can look at the national problem, and we can look at, but we have to determine the scale at which we're working. But there's bigger factors at work here, and this is another what you need to understand working as an environmental professional is the importance and necessity of scale dependence and shifting your lens based on the scale that you're looking at. So in my work, I deal with the national governments of Caribbean countries, but I also deal with the international organizations that deal with all of those countries, right? So I have to shift my lens occasionally when I go to a big climate meeting or biodiversity meeting for all the countries and say, okay, let's look at the big picture here. How is biodiversity doing globally, and how do we measure that? Or how is climate doing globally, and how do we get that data? And then I have to zoom in when we're working for like St. Lucia or Antigua right now and look at specific data, like what are they measuring? How is it going? What about what's the issue? Sea surface temperature, like in Antigua, that's one of the ones. Coral degradation, sea rise, amount of storms. Could be something different in Africa and like Chad or Sahara, or wherever. Like in Ethiopia, it might be something different. So those scale issues are big. You need to shift scale. In this case, I want you to also look at this from an Earth system standpoint. So this is a phenomenon that's really hitting the radar right now in the west coast of North America, the Pacific Northwest, as well as in California and in British Columbia and across Canada as well. But it's also an issue that's global, and there's some global cases we can look at to get a better handle of that. So I'm going to send you some Earth system stuff right here, which again, these are all included in the PDF. So if you look at that article there, this is a good one. I don't know if you can download that one right away, but you can, through Railroads, for sure go and access it through the library. I'm just going to pull that one up. This is from Australia, CSIRO, which you don't know them. They're a good group, research group. Forest fires and climate change, causes, consequences, and management options. And this is looking at like this global type of phenomenon of forest fires. Now, this is from Australia, right? So they've got a wildfire problem there as well, because that's where they're based. But this is a good paper on looking at the phenomenon, the relationship between climate-weather interactions, vegetation, and human interaction. And you'll notice there's Flanagan is cited here and so forth, a familiar author, right? A lot of these people who become experts, they're highly cited. So that's a good one for looking at this kind of the global issue of fire severity, wildfires, and then how it plays out in different regions. In China, it's not just in North America, happens in Australia, happens in Indonesia, happens in Africa, happens in Siberia. There's big fires like a month ago, right? So you need to also think of this from a global standpoint. Amazonia, right? Do you remember last year there was fires in Amazonia? This is when you're looking at things from an Earth system standpoint, you have to look at the different contributing factors, right? So those, you must remember that those fires were going crazy in Amazonia, right? So here's some paper on that. Now I have a little more closer view of that because I worked on it. So if you look at that paper, okay, this one looks at fires in Amazonia, which are interesting. Forecasting fire season severity in South America using sea surface temperature anomalies, okay? I'm going to bring this up because when we look at the kind of the relationship between different things, you need to look at the causal factors. So that's one that looked at southern tropical sea surface temperature in Southern and South America and its relationship with fires, okay? Here's another one, another link that I want you to look at. All of these articles you need to get through the library if you want to get the full one. This is just the abstracts, okay? This one here is from 2008. In 2005, there was a drought in Amazonia. Folks, Jose Marengo and Carlos Nobre, I know those two people, and met with the rest of the team. They wrote this paper, and they are modelers. These are climate folks. This is a journal of climate. They are serious people. And they did a study of the relationship between the Amazon drought in 2005 and the fires, which I will show you, and the relationship between sea surface temperatures anomaly in the southern Atlantic. They did the modeling study of that. This is a really good paper which looks at the relationship between the sea and the meteorological conditions that created that drought and therefore the fires. Okay? And then lastly, second to lastly, cities may also be engineered with better wildfire precautions. Yeah, I can get to that. It's a good point. Thank you for pointing that out. Okay, and this next article here, so we've seen that there's linkages between different things, right? Some the El Nino, but that wasn't the El Nino. This one is fire responses to 2010 and 2015, 26 Amazon droughts. So this one here, if you look at this paper in Frontiers of Science, this looks again at that issue in Amazonia, extreme droughts in Amazonia causing fires and instability in environmental, social, and economic systems. So those in 322, environment, social, and economic imperatives. Right? And this is a good paper that looks at all of the things that go together in influencing a situation. Okay? This is the good stuff. These are the real sources you want to look at. And then lastly, I'm going to show you something that is my own stuff that I did in 2008 here. So if you want, you can. If you click on that, that's going to take you to a website which you can download a thesis that I did, which actually measured this stuff. Okay, I was so interested in this whole area of Amazon and climate and Amazon and interaction between ecosystems, the atmosphere, and what goes on in Amazonia that I spent 3 years studying it and did a thesis on it. And it's not, surprise, surprise, that was in 2008. So if you click on the left, download PDF, if you download that PDF on the left-hand side of that link that I just sent through, that will give you the PDF of the thesis. And if you look at, on that, if you look at just the data that I gathered on that, which is in, just one sec, page 49 and 63, in that big PDF, a big thesis. I'm not tooting my own horn. I'm just saying, like, if you measure this stuff, you get down to the real deal. If you look at those pages, page 49 and page 63, I measured using satellites the number of fires. And back then, I saw the relationship in the data between what was per month fire frequency in 2001, which was a non-drought year. There's a cyclical. If you go to page, so that's page 71 of the PDF, and it's page 63 of the actual thesis. But in page 71 of that PDF, you'll see in that graph there, January, February, March, this is a month, your average month, but then the one line is 2001, the other line is 2005. So you can see that there's a pattern every year in the Amazon where it's like, okay, January, February, March, April, that's pretty rainy and not that dry. But traditionally in June, July, August, September, October, November is the dry season in Amazonia. There's always more fires every year, the way it goes. 2001, there's more fires, it subsided. 2005, there was twice as many fires, literally, well, just under twice as many. Why is that? Because if you go to that Marengo paper, there was a big drought in 2005, right? And what is associated with that drought? What is associated with that drought is a sea surface temperature anomaly in the southern tropical Atlantic. The southern Atlantic was warmer that year than normal, and it caused there to be a more extreme drought, which then caused there to be more fires. You can see it. And guess what? According to the modeling, the global modelers, Marengo and others, they have found that the increased amount of CO2 in the atmosphere leads to more energy in their system, which accentuates these dipoles. It accentuates that warming of the sea that is cyclical. It normally happens. It's a regular thing. It's like the El Nino. So it just happens. It's the way the Earth system works. However, from the data that they have found in the modeling they've done, climate change, the amount of greenhouse gases in the atmosphere, seems to accentuate that, makes it a stronger dipole, which therefore leads to stronger droughts, which therefore leads to more fires. Okay, it's in the data right there, and it's in the legitimate analysis done by, Marengo is no slouch. That guy's like a ninja when it comes to climate stuff. So that's how you deconstruct this stuff from an Earth system standpoint. Sometimes there's these regular things that happen, but then there's anthropogenic factors that may contribute to it. And that's at a global scale. Then you got to drill down to the regional scale. Okay? Good. So that's how you can start to tackle this, break it down if you want. So is fire bad? Well, it's actually a natural process, as we've discussed. We do want fires to occur. We want them to occur. It's a natural process. We want to cull forests sometimes. We want them to regenerate. We want to reduce the amount of load in the forest. There's not as much standing timber often. That's why it's called this paradox. So the issue is, how do we manage this situation? How do we deal with it, right? Well, this is where we roll up our sleeves and we do it with environmental management tools, okay? And we need to look at what tools we have available to us. So guess what? In Canada, we are pretty good at this. We have an amazing Forest Service, and we have really highly qualified government scientists and policymakers who keep their eyes on this stuff. So the first thing, we need to have some sort of policy group who focus on this. So in Canada, it's these folks. NRCan, Natural Resources Canada. So if you go to that website, see that this talks about forest fires, right? Talks about wildfires, wildland fire management, balancing the bad and the good. This is what we have to do, right? We need to have, mechanisms to control them, but we also, some fire, not all wildland fires should or can be controlled. Forest fire agencies work to harness the force of nature and natural fire to take advantage of its ecological benefits while at the same time limiting its potential damage and costs. This makes fire control strategies a vital component of forest management and emergency management and environmental management in Canada. All right, so we're on top of this stuff. So within the context of the work that NRCan is doing, we've got specific things, systems in place. For one, in Canada, we have something called the Forest Fire Danger Rating tool. So many of you have gone camping and you've seen those signs, seeing like whether there's red, green, it's on that slider. Has anybody seen that before? Yes, you have. Most Canadians who've ever been to a campsite have seen that, right? Well, this is where it comes from. Bang. It's NRCan that does that analysis. Natural Resources Canada does the analysis to tell the parks ranger or whomever the field officer is what the risk is in different regions. Therefore, that's why you do campfire bans sometimes, because if the risk is super high, they don't want people lighting fires. And just things happen sometimes. But that's this system there. If you go to that link, that's what it is. It is a system that dictates whether the risk is high or not based on science, determining through meteorological and also vegetation cover and so forth, whether or not it's low, moderate, high, or extreme fire danger, right? So there's two main parts of it. You have human-caused fires and lightning-caused fires, and this is how they come up with this. Fire managers use this system to anticipate the potential for daily fire ignition across the landscape and looking at the two kind of major categories. But it's this Canadian Forest Fire Weather Index system, which gives you primarily the weather readings, which will tell you if the risk is high or not, and then you put on kind of what's the risk based on how many people are there and ignition sources and stuff like that. But you need that kind of ranking system in the data to then support that. You also need an information system to determine what is going on, right? So where are fires when they're happening? So we have something in Canada called the Canadian Wildfire Information System. So if you go to that link there, this will take you to, it's very cool, is to the Canadian Wildfire Information System interactive map. So you can go on that and then you can select any day, right? So for instance, if we want to select, I don't know, I'm going to select the 12th of September 2020 and retrieve the map. This is then going to call to their database, and it's going to then create a map of showing me, it's coming, it's taking a bit of time, the fire frequency. Not getting it come up, strangely. Overlays, fire danger. And it will give you the fire danger. You can overlay the hotspots, fire perimeter estimates, all that kind of stuff. Okay. Is everybody able to add up? Yes, no? Can you see that map? Cool. So if you look at that, you'll see, I'm not getting actually the fire data coming up right now, strangely. I don't know what's going on. I think maybe we're all looking at the same time. It's choking the system. But what they will give you, and what they do, this is derived based on satellite, a combination of different data sets. One main one is MODIS. It's a satellite that goes overhead that's relatively coarse resolution, so 500, 250 meter, 500 meter, 1 kilometer. I think they use 1 kilometer spatial resolution pixels to determine whether there's a fire risk and so forth. Because MODIS, it's from a satellite and it looks at what's going on the planet Earth. You can see temperature, you can see vegetation, that kind of stuff. And you can see fires when they occur. So we're taking satellite data and weather data and so forth and processing it and producing these interactive maps which tell us what the fire risk is and fire frequency in different regions. Very, very handy. The thing is, it's relatively coarse resolution, so it doesn't allow you to see specifically what's going on in the fire, like in a valley, for instance, right? It's to see at a broader scope of things. This is the kind of stuff I used when I did the assessment in Amazonia. It's actually literally the same data. So we have the Canadian Wildfire Information System, but we also need to understand and model fire behavior, right? The actual fire, like what we expect. We can see where fires occurred, but we want to know, we want to have an idea of how a fire might behave. Okay, so take a look at this link here. This is, again, part of the Canadian Wildfire Information System, and this is the summary of dictating of explaining what it covers, right? Like what is within this system. And it's not just fire frequency. You can see that if you go to that link there, you'll see you can fire monitoring, mapping, and modeling. M3, right? Monitoring, mapping where they are, and modeling. And modeling allows you to predict what might happen, right? Behavior of fire and so forth. So they give you a really good description of what they're using. So it's CCRS, which is the Canadian Centre for Remote Sensing, and the Canadian Forest Services, and NRCan. Well, they're both part of NRCan. They're different agencies with NRCan, work together to process and access satellite imagery, as well as getting data from NOAA on atmospheric data, and produce these products, which if you look at the other ones, so we have those components, we have hotspots. So if you look at this one here, this link here is hotspots. Okay, if you look at that, that will tell you, or show you, sorry, where the daily hotspots are for fire. So if you can look at, I don't know, I'm just going to retrieve a map. So I just retrieved the map for September 10th. Okay, and you can see where the hotspots look. Not surprising, a lot of spots are in Oregon, right? There's some in BC, but the one for September 10th is mostly, from what I can see here, is down in the United States there. We're pretty good in Canada right now. We're not so bad. So there's hotspots, and then fire behavior. So fire behavior is how does a fire actually evolve, right? And that's going to be a function of the fuel. It's going to be the fire head. So if you look at this link here, bang, that's going to give you fire behavior. So if you look at that one, hotspots, just where the fires are. Fire behavior gives you intensity maps, fire head intensity, it's kilowatt hour per meter, like how strong is this fire, basically. So you can see crown fraction burned, the rate of spread, total fuel consumption. These are kind of more behavior things, foliar moisture content, which will help inhibit fires. So this is more out how things are working, right? Again, all important parts of managing and predicting how fires will evolve. And as we get into the environmental management stuff, you'd see that's very important data to have. And then you also need to deal with how do we respond to this. So this is back to the comment made about the, like, how do we react to this, right? So we had CAM, cities may also be engineered with better wildfire precautions. Exactly. So there's ABC's link, but we also have that in Canada called FireSmart. So if you go to that link, this big component of making cities or communities more resilient to fires, either through preventive measures or understanding the risks of evacuating, all that kind of stuff. So FireSmart is a big component of how we react to that. It's an environmental management strategy and policy tool. So then, there we go. We've got some data, we know what's going on, or at least have a course idea of what's going on. We've got some programs to help communities become more resilient, but we need to think about these trends. I've shown you from the Amazon that there are linkages between, and also from the previous papers, these are connected, and fire, right? So we need to then have a better analysis and dig deeper into that. So if you look at some of the trends in Canada, not Amazonia, here, NRCan, climate change adaptations. These are some of the things that we've been working on in Canada about understanding these risks, right? So that link there talks about impacts, climate change impacts on forest, right? So you can see increased fire activity, the majority of infestations, aspen dieback in prairies, and this outlines how climate is interacting with forests, which is a precursor to fires, right? So we need to have information, but we also need the actual data. And I've shown this to people before, but for those that are new, we've got some, and this is new, this is only in the last year or two that this has come online. We want to do the analysis. So check this out. Guess what we have? We have climate services. So if you look at that link, you can go on, if you happen to get hired to be the fire manager for a community somewhere in Canada, and you want to look at, you want to show them you know what you're talking about with respect to climate change, you go here, Canadian Centre for Climate Services, and then you say, okay, well, we need to look at the climate, future of climate in this region. Say I got hired for Nanaimo or Nelson or someplace like that. I go on, bang, with this, then I go, that's the Climate Services website, and this is the actual climate data. You go there and you explore by location. You choose a location. So we're going to go, let's do Nanaimo. No, let's do a fire-prone region. Where's a fire-prone region? Give me a name. Give me a city to look at. Fernie, done. Fernie, I'm going to go Fernie, Kelowna. Fernie wins. Okay, so I just went Fernie here. I typed in, I don't know if I typed in Fernie there. I don't know if that will come through, but I just typed in Fernie, and then it gives you the temperature, and there we go. And it will give you the climate model for Fernie, expected increase in temperature, hottest day, and the different model output, RCP 2.6, 2.4.5, and 8.5 range. So these are all the different model output from 2000 up into 2100. And then you can look at that on the map, right? So you want to see this, how this looks geospatially. You can see it gives you the climate, it shows you Fernie, right? And I can zoom out. You'll notice if you look at the map part of this here, that it's kind of, these are big blocks, right? Big chunks. Like Fernie is like, it's just one small piece of Sparwood's there. It's this big square. The reason for that is a global climate model output. Global climate model output is, I think it's 8 to 10 kilometers squared, depending on how you scale it. So it's a big piece of land, what they're predicting, because it's a big, you know, it's a global model output. So it's, but you can then change these, right? You can look at the hottest day and so forth, and you can really, you know, this is how you can do some pretty good analysis. And if you zoom out, you can see where it's predicted to get a lot hotter. And if you look at the actual big picture in Canada, it's southern Alberta is looking like it's going to get a lot warmer, right? So this is a tool now as an environmental manager, right? An environmental management tools expert. You can use this to predict where you can see global climate model output and how it will look like in the future, how we expect it to look like. This is a starting point, because then you can start to say, look, we're going to be really hotter in the future. We need to like take care of this. And last, to conclude, we want to look at, or not to conclude, but look at how do we respond provincially then, okay? So if we're looking at Fernie, we'd say, okay, well, like, what are we doing in provincially? Yeah, very cool. Like, this is freely available to you. You can jump on and do this all over the place. That's BC. So in Canada, it's provincial. You have a wildfire service in each province. So wildfire service in BC deals with BC. They interact with NRCan. Here's Alberta's. That's Alberta's wildfire group. Here's Ontario's. All of these links are in the PDF that will be downloadable, so you don't have to worry about it. Manitoba, okay, Saskatchewan. So every province has their own group. And in that one paper I showed you, how they interact. And then lastly, we have something called the Canadian Interagency Forest Fighting Center, which is a group that works with all of them. It coordinates between all of the different firefighting agencies, CIFFC, okay? And they look at, you know, how to use data, response processes, what if you need to have groups work together, all that kind of stuff. So you have a lot of collaboration amongst different provincial, and you have NRCan working federally. So together we've got a pretty good handle on this stuff. We can always do better. So lastly, you got all this information. We're pushing an hour now. What does this have to do with environmental management tools, right? Because this is the subject of this. Technically, some of these things I presented are environmental management tools. Predictive capability, fire danger ratings, looking at the climate impacts, looking at the fire behavior. All of those things are modeling and predicting tools you could use. But in addition, if you're working for an organization, like a company, you might want to consider building some of this stuff into your environmental management system, which is the system that a company or organization uses for managing and understanding environmental impacts, because there might be risks you have to deal with, or risks to your supply chain. Big problems for energy companies, right? You might need to think about this. Fort McMurray, look at what happened there. You might need to think about environmental impact assessments and strategic environmental assessments, EIAs for projects when you're building a new project. If you're building a project in a region that's prone to forest fires, you might want to think about that beforehand. That should be included in your EIA. Now, if you're crafting policy for disaster risk reduction or anything like forestry, which would be something, a strategic environmental assessment is an environmental management tool for policy and planning, you'd want to build in some sort of fire risk component to it, particularly for forestry or even community development across a region. And then lastly, LCA, life cycle assessment. Never thought of using EMS for one. Exactly. But you think about it, like it makes sense, doesn't it? You could use an EMS for wildfire management. SEA makes a lot of sense, obviously. Even an EMS makes sense, I would argue. What if you're operating a company that's in an area that is prone to forest fires? You might want to build that into your EMS. SEA makes perfect sense. EIA makes a lot of sense. If you're doing a project that's subject to fire risk, you might want to consider it. And LCA as well. There we go. And elaborate on the LCA. Well, this is one, you know, I would think that you'd want to think about, like, say, LCA if you're dealing with forest products, or anything where you're drawing on forest products for your production, right? So imagine if you're producing guitars, right? You're making guitars from forests that come from British Columbia. If that's the case, your supply, wherever you're getting it from, you might want to consider the risks associated with that, right? Because you want to know where you're getting that impacts. You also want to know the risk to your supply chain, upstream and downstream. And therein lies the use for LCA and the implications for forest fires or wildfires for that production, which you would capture in an LCA, right? As you know, with LCA, LCA is designed to look at the life cycle of something, a product or a service even. And you capture that, depending on what you're looking at. Wildfires could be something, or fire in general, that would impact the life cycle of a product or a service. So even like there's a lot of different ways that environmental management tools interact with wildfire management, either at a micro scale from an organization or a production standpoint, at a provincial scale or a community scale by looking at, say, risk assessment, or even at the national or global scale by looking at global climate models, looking at fire risk, and all that kind of stuff. All right, so there you go. In 1 hour, you have gotten a download on wildfires. So if you get in a debate or a discussion at a party on the weekend where people start talking, you shouldn't go to parties because we're not supposed to be socially gathering. So I'm not advocating that. If you get in a conversation with people about that, this is stuff that you know. You can dig into these links and have a much more informed way of saying, look, this is how we can deal with this situation. We need to use the data for future climate modeling. We need to look at fire risk that American is producing. We need to be fire safe, which are community programs that exist in Canada. And then we also need to look at the organization or community or individual or organization level, how we can use like things, tools such as environmental management systems, impact assessments for projects, strategic environmental assessment and life cycle assessment, and perhaps even eco-labeling, that kind of stuff, standards and certifications to address and deal with the risks of wildfires and the impacts of wildfires. Boom. Any questions? Makes sense. Does this make sense to you? Linda's on fire. I didn't include much about the US. I figured focus on Canada, but they have similar types of systems and processes in place. Okay, Joseph. Do you think that overpopulation, increased population in rural areas, and impact of our human population has a lot less weight in increased fires compared to climate change that promote the position of human as a main cause? We'd have to take a closer look at that. It's a great question. Excellent question. That's the kind of question where you need to dig into the data, right? It's what expected. So how I would cover that, how I would address that, I look at the climate model output and the fire risk. So there's probably, I'm sure someone has looked at, like look at Flanagan or someone who's done a projected increase. Even in that one paper, I think they probably have what we expect, where we expect those fires to occur. And then I would look at population growth and population density, and I would overlay them. If I were to analyze that in GIS, I'd take the model output as to where we expect those fires, modeling, and you'd have a geospatial layer, and then I'd look at population and population increase projected and see where they interact. And it's gonna see like where there's more population, more fire, more damage. But I don't know off the top of my head of a paper that has done that, but that's how I would approach it. It's a great question. But that's the question you need to ask, and that's the approach you need to take in order to really assess these problems. What I find irritating is the simplistic dialogue that we hear on the news on it, that is often highly politicized for whomever's purposes, right? Okay, climate change is not a problem, right? So he's appealing to his base to say, oh, it's going to cool down. Well, it doesn't look like it. And then on the other side of things, those that say, oh, it's all climate change, where they don't look at population, they don't look at, some of these things like forest management, which is a big part of this as well, that we need fires, right? And maybe we've not been managing it properly in some cases. Maybe in some cases, some of the fire management groups have let load build up such that we had way too much standing dried wood, and we need to change that, right? So it's probably a mix of both things, right? I would say. And then the risk, where are all the people? If it's burning out of control in a certain region, and it should be burning because we need to have that regeneration occur, then fine, at least we know. Anybody else? Could an EMT support developing appropriate fines for pyrotechnic? That's great. Yeah, I think they should be fined. Yeah. Why the heck would you do it? I don't know. I mean, it just seems insane to me. Where you have like super dry conditions and you decide to do I don't know. Yeah, we should have that. Monitoring. You need to monitor. I mean, it would be an environmental management tool as part of the communication stakeholder engagement, right? For those who've done any EMT courses, Stakeholder communication is a big part of that. So we got to rely on two things with that. COVID's the same way, same issue. We got to rely on people to self-regulate, like don't do things that could cause harm to many, like having a gender reveal party where you light off fireworks in a drought-stricken region. That to me doesn't seem like a good idea. Probably something someone shouldn't do. But if they don't self-regulate, then we need to regulate, plain and simple. And we need to have regulatory tools to address that. Similarly for COVID, right? No matter how you think about that, there is an obvious trend in community spread in social gatherings. If people can't self-regulate, like we've seen in Vancouver, speaking from where I am, then we need to regulate. That's why they closed down bars, because people were just going to bars and it spreads like crazy there. Even if you're not dying, if you get sick, it can propagate the spread of the virus, which is problematic. So that's it. But you need the systems in place, and risk communication is a part of that. That's a big area. It's like, risk communication is scaring people or calming people down, essentially. You have to scare people when they're not behaving accordingly. Drunk driving, scare people. Why? Because the data shows that when people drink, the accident rates get higher. So we need to scare people and show them that so that they don't drink and drive. That's called precaution advocacy. And then outrage management. Sometimes things are innocuous and people are freaking out, right? Like, I don't know, nuclear plants sometimes can be, that's one of the things where there's low risk often and people are freaking out. And there's other examples of that where you need to like calm people down, say, look, we need energy or we need this. We need to, present to them and talk to them and calm them down. But yeah, any other questions? All right. Thanks for coming out. It's an action-packed one. There was a lot of stuff to this one. Any requests now? Any requests for podcast topics? I've got some requests. I've got like about 8 requests from my previous class today I met with. Anybody want to hear about anything particular going forward over the next 12 weeks? Nothing specific? I'll send out an email too. All right. Keep it in mind and just email me, and I will take your request. I might send out a batch email from the reminder to send requests in, because I want to, obviously do stuff you're interested in. All right. Thanks for coming out. For those it's your first time, we went a bit long, but not too long. But I think it was worth it because we covered a lot of stuff. This again is going to be posted to the YouTube channel. The PDF will be accessible through the description as a link. You will drop, and you can go to the description of the video and click on that link, and you get the PDF with all of these links on it. So don't worry about writing everything down. I will let you know when the YouTube video is up, and you can go get that. And that will be helpful for you when you go off and try and fight forest fires or get hired by Enercan or whomever. All right? Okie dokie. Thanks for coming out. Stay safe. And for those in the classes, we'll welcome aboard and we'll see you online.